Automated line-art colorization is the market-demand research field owing to its expensive, time-consuming, and labor-intensive workload. And recently, data-driven colorization methods have actively explored to grasp high-level semantics. Generally, to deal with the lack of data problem, synthetic sketch extraction methods have been adopted to utilize abundant real color images. And here, it is important to reduce the domain gap between the real and the synthetic sketch to improve the generalization of colorization model. Typically, the pipeline of synthetic sketch extraction is composed of three common steps. The first one is the resizing for scale normalization, and the second one is the line detection, and the last one is cleaning, such as binarization, thresholding, or simplification. In this study, we mainly focused on the resizing step. To resize the scale of the input image, most of the studies adopted an early resizing stage, which means the resizing step precedes the line detection step. In most cases, it is for the purpose of saving data stretch or reducing complexity. In conclusion, we analyzed that there are potential risks hidden in the early resizing stage. First one is it can degrade the quality of source color image, and the other one is it can causing so-called lookalike bias problem. In the early resizing stage, the resizing is performed by interpolating color and line segments. It can result in aliasing problem. This distortion can deteriorate the quality of line detection results. The other risk is that the interpolation at the color level can also cause a lookalike bias problem. For example, in the color area where difference with the line segments are ambiguous, line segments will be extracted thick and dimmed. These artifacts can work as unintended priors, which denote the intensity of the target color area. Note again, this ambiguity can be worsened by interpolation at the color level. And as a result, this bias can degrade the generalization of colorization model. The goal of this study is elaborating inherent risk in the early resizing stage. And we analyzed that the late resizing stage can elaborate the aforementioned problems. Firstly, in the late resizing stage, the interpolation between colors and lines is naturally avoided, so the quality degradation problem also can be prevented. As a result, late resizing leads to extract the more realistic lines. Late resizing stage also has an advantage of downsizing augmentation. In the inference stage of colorization, the size of an input sketch should be normalized to the proper target size of the colorization model. Thus, reproducing the influence of interpolation, such like anti-aliasing effect or pixel subsampling, is another objective of the sketch extraction process. The late resizing stage, such influence is naturally reproduced in the subsequent downsizing process. Does it help improve generalization of colorization model? And also, in the late resizing stage, the interpolation between color area and the line segments is naturally avoided. Therefore, the aliasing problem between color area and the line segments can be prevented.